Hello everyone, welcome to Yukaria. I'm Victoria, and today we're going to solve Leetcode 141, linked list cycle, and we can read the prompt real quick. Given the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pause is used to denote the index of the node that tail's next pointer is connected to. Note that pause is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. So let's take a look at the examples. Example 1, we see a linked list with a cycle in it. It goes 3, 2, 0, -4, and then loops back to the second node that also has 2 as a value. And then it proceeds to 0, -4, back to 2, 0, -4, and we can loop infinitely. Now before we solve the problem, let's take a look at the other examples. Example 2, we see it goes 1, 2, and back to 1. And then in example 3, we just see a node with value 1. All right, so, and then we should take a look at the constraints. The number of the nodes is in the list is in the range 0 to 10 to the 4th, and then nodes can have a wide range of values, and there may or may not be a cycle in the list. So what we can do to solve this problem is we can take a slow and fast pointer approach. So 2 pointers. The fast pointer will move at twice the rate of the slow pointer. And that way, if the fast pointer ends up catching the slow pointer, we know we have a cycle. And so we have to be cognizant of that we might be in a situation where we have only one node given to us. Or, yeah, so we want slow and fast pointers to both start at the head. And then we can track our fast pointer. So while fast and fast.next. So we want that pointer to have a value as well as its next for the sake of this loop. Now, first things first, we need to advance the pointers. We can't have them start. If they're starting at the head, then initially they'll be equal, so we want to break that condition first and also handle the general case of our loop. So we advance slow by 1, so slow equals slow.next, and we advance fast by 2, fast equals fast.next, and that's why we have the fast.next check in our while loop. Now we can check our cycle condition. If slow equals fast, return true. It must have a cycle. That's the only way that you would get them to equal each other. And if you can make it out of that loop without a cycle, then you can return false, no cycle. And we see that's accepted. And it's also accepted. So pretty straightforward problem. However, it's easy to make a few mistakes. So as I was warming up for this one, I made a couple of boneheaded errors. I made the mistake of forgetting that I can't just set fast to fast.next because I might not have a node there. And then I would get, a none type situation, and Python would raise an exception, and then I look a little foolish on camera. But anyway, but the general idea, and even if you make a mistake and have to rerun it a couple times to tweak it, is pretty straightforward. If you use 2 pointers and one of them is faster than the other, if there's a cycle, they'll eventually the fast one will come around, equal the slow one, and you'll have detected it. So with that said, I just wanted to mention that this video is dedicated to Ethan Nash of Myriad Genetics, who had requested a linked list problem for me to solve. Well, thanks everyone. Take care.